Good morning and welcome. It is our great honor to spend some time with you today talking about this new generation of technology and what it really means and how big it really is. I've been in the information technology business for some decades now. And when I got involved, I'm a computer scientist. When I got involved in the information technology business, the global market for information technology was about $200 billion. Today, say 4.5 decades later, it's about 9 trillion. So we've seen some growth, and so it's really quite remarkable. And we've seen these bubbles over the last 40 years. And these bubbles actually go back hundreds of years. In recent years, for example, after the Civil War, we had transcontinental railroads, and the market knew that transcontinental railroads were important. And the way that markets do, they like way overvalue these things. And so you get to the mid 19th century, say 1870, we had, 1870s, we had a huge recession when the market corrected. Kind of the next huge market bubble was associated with urban electrification. Okay, this would get us into this brought on the roaring 20s. Okay, the market went crazy. Everybody was, pounding on their chest and dancing all night and drinking champagne in New York. And then the wheels came off with the Great Depression, from which, it might have taken, I don't know, 15, 16 years to recover. That was something of a zinger. Now you get into the information technology business that, as we think of it today, probably began about 1948 with the invention of the transistor. We've seen some bubbles. And so how big is this bubble associated with AI? Well, guys, it's big. I mean, it's huge. And we've seen this movie before. I assure you, companies do not trade, okay, at 100 times revenue. It just doesn't happen, okay? So this is people actually, when it's happening, they believe it's real. But, the laws of physics apply even in Washington, D.C., okay? And, gravity does, it comes back into play. So you kind of think back, 25 years. We had companies with, staggering valuations, Yahoo, Netscape, Cisco, Intel, some of them running, monopolies like Intel clearly was at the time, Microsoft clearly was at the time, and they're not anymore. Okay, but these companies had these staggering market valuations, and these people, Steve Case, Jim Barksdale at Netscape, I mean, they actually believed this stuff, okay? I think Cisco was trading at $500 billion. Intel was trading at $500 billion. Does Netscape exist? Anybody ever heard of Jim Barksdale? Does Intel exist? Okay, let me help you out. In 2000, Intel was a big deal, and so was Craig Barrett. Anybody ever heard of Craig Barrett? Okay, does Yahoo exist? How about AOL? Anybody use AOL today? Anybody heard of Steve Case? Probably nobody here's heard of Steve Case. And so these things, they come and go. And I've seen this movie before, okay, and this too will pass. Now, were transcontinental railroads important? I mean, come on, they're huge. Was urban electrification important? Huge, okay? Was the internet important? I mean, however big we thought the internet was in 2000, I mean, it's 3 orders of magnitude larger than that today, right? But, so this market too will correct, and, we'll see, 80% of the companies in this business will no longer be in business. Let's take an example like OpenAI. I mean, OpenAI, fine company, ChatGPT, fine piece of technology. If we read in the newspaper this Sunday that OpenAI had gone out of business, nobody here would be surprised. And it wouldn't matter. I mean, it would be by Monday, I mean, by within a month, we will have redistributed that human capital across the industry, and everybody uses ChatGPT will use Llama or Claude or a product from Anthropic or Mistral or whatever it might be. It could disappear next week and it wouldn't make any difference in the world. Will these companies disappear? Absolutely. 8 out of 10 of them will disappear. Take it to the bank. But now let's take a look then. Let's kind of stand back and look at kind of what's going on here with the AI stack that's out there. If you put it from the bottom, you have silicon, infrastructure, foundation models, bright, shiny objects, and applications. And these are all being, incredibly well valued by the markets today. And let's kind of take a look at each one of these. Okay, at the bottom, at the bottom of this we have silicon, and this would be today NVIDIA, AMD. I guess Intel's still in business. I think they're about to become a part of the General Services Administration or something. Okay, and but this is I think roughly now you guys know I'm blind, right? And so I'm blind as a bat. Okay, I lost my eyesight in February. So they used to say I could see around corners, and now I can't see the step in front of me. So I'll be lucky to get off this stage without falling on my face. Anyway, but if we look at the market cap of these, really the silicon companies, which are the foundation of this, I guess there's probably $6-7 trillion there. We get into the we look at the infrastructure companies, people providing cloud infrastructure, massive parallel computing, massive storage at low cost. Microsoft Azure, AWS, GCP, Oracle, and I think there's about $9 trillion in market cap there today. On top of that, we have foundation models, okay, and that would be OpenAI, Anthropic, Mistral, etc. I guess there might be $500 billion in market cap in those companies today, and that's a very, very fluid area. Okay, on top of that, okay, we have bright, shiny objects, things that do things like persistence, key value store, platform independent relational database like persistence, Snowflake, virtualization, Databricks. And you add all this up, it's probably most of these bright shiny objects, Snowflake aside, I think you're dealing with probably $500 billion in market cap. And what do we use all this stuff for? I mean, we use all this to build applications. How many companies that are in the AI business today will not exist in probably 8 out of 10 will not exist. Okay, and we'll kind of see who the survivors are. But the market knows this is important. How important is it? It's huge. Now, there's really nothing new here. I mean, when we get to AI, okay, there's not much that wasn't invented by Marvin Minsky in 1950 at Princeton, right? That would be supervised learning, that would be unsupervised learning, that would be TD learning, reinforced learning, neural network. See Marvin Minsky, Princeton for details, okay? The only thing that happened between the AI winter, which gets us from about 1950 to maybe 2020, so that's about a 70-year run, is the lack of computing and storage capacity. And now with the kind of, I would say the acceleration of Moore's Law with the elastic cloud, where today we can spool up tens of thousands of virtual machines executing 24-bit floating point operations in parallel at 3 gigahertz cycles, and storage is basically infinite and free. We're able now, that combined with this phenomenon that has kind of come and gone and is now ubiquitous, that we call the Internet of Things, enables us to solve the problems that were defined by Claude Shannon and Marvin Minsky, and others in New Jersey about 1948, 1949, 1950. Now, there is something new here, though. Okay, what is new are these generative pre-trained transformers. So we'll talk about that separately. These large language models, this is a genuine new idea. It is a big deal, and there's a lot of utility there. But all this kind of pounding on the chest that we see in the market of all these people that have, are defying gravity, they're doing things that never been done before. I mean, come on, guys, get over it. Okay, this is not the way this works. Okay, 8 out of 10 of these companies go out of business, markets reset themselves, and fundamentally, the companies that survive will be the companies that deliver value to their customers. So let's look at C3 AI. Okay, we got started in this business in January of 2009, and we spent, I guess now $3 or $4 billion, okay, building a software stack. And the idea when they buy, this is kind of the software stack is called a model-driven architecture. Okay? And what we have are all these models, these software models, be they machine learning models or be they models that do persistence or, the hard stuff is not machine learning, guys. I mean, supervised learning, unsupervised learning, TD learning, reinforcement learning, it's not that hard. Okay, you get into these large, complex systems at the scale of the Air Force, at the scale of DoD, at the scale of Shell, at the scale of a large utility, at the scale of ExxonMobil. The issues are dealing with data wrangling, data persistence, organizing the data, queuing, ETL, access control, N-factor authentication, pipeline management associated with millions of machine learning models. Hey, that stuff is tough. Okay, machine learning is easy. Okay, that is the coordination of all of these data across all of these machines and all of these users that is really, really hard. So this is what we set out to build. Beginning actually in 2006, we began work. 2007, 2008. In earnest, we started spending money in a big way. And this is like real money. This is not like, this kind of stuff you guys deal with around here that they allocate in Congress, okay? This is like not Beltway bandit stuff. This is like real cash. And I guess about $3 or $4 billion that we spent. And building all of the services necessary and sufficient for people to design, develop, provision, and operate enterprise AI applications. Okay, now this we began in 2009, and you get into, and we're talking about enterprise AI applications in 2012, in 2013, in 2014, in 2015, 16, 17, 18, 19. You know how many people were talking about enterprise AI applications in 2016? Okay, you're looking at them. Okay, nobody cared about any of this stuff. I would say that nobody really cared about enterprise AI applications until November of 2022 when ChatGPT was released. Okay, during the Davos event, and that was a big deal. All of a sudden, now everybody's talking about enterprise AI applications. Now, let me talk a little bit about enterprise AI applications and how they evolved. Okay, this was built on relational database technology, which we can get into sometime. Incredibly useful piece of technology. On top of that, we built tools that relational database. For those of you who played with that, uses a language called SQL or Quell. It's basically not a command line interface, but it is a language that we use to store data and manipulate data, update data using a relational algebra or relational calculus. We would manipulate sets. It's a set theoretic problem. Now, then we developed tools like SQL Forms, SQL Reports, what have you at Oracle. We developed the equivalent at places like PeopleSoft and SAP, so we could represent these data in columns, in rows, and numbers on a screen. So we would develop an abstraction of the financial system, or an abstraction of the manufacturing system, or an abstraction of the production system, CRM system, whatever it might be. And this abstraction would do sales forecasts, customer churn, inventory levels, what have you. And when we introduced relational database technology in the market in, say, about 1980, 81, 82, it wasn't whether you were going to buy it from Oracle or Ingress or IBM. people were going to build these relational database systems themselves, including DoD, including Westinghouse, including digital. Well, nobody succeeded at it. When then we introduced applications like ERP, CRM, manufacturing, it wasn't whether you were going to buy this from Oracle or SAP. People were actually going to build ERP applications themselves, and they tried, okay, and they failed. Ditto with CRM. When we brought that to market in about 1993 is when we invented the CRM market as you think of it today: sales, marketing, customer service, marketing automation, product configuration, what have you. And everybody was going to build that themselves, from Microsoft to IBM to Pfizer, Deutsche Bank, Lufthansa. And so everybody tried once, twice, 3 times to build it themselves, and then they threw it in the towel, and IBM decided to buy it from Siebel, and Microsoft decided to buy it from Siebel, and Hewlett Packard and Pfizer, and so I think we had about 85% share of the CRM business industry when we sold that to Oracle, Siebel System to Oracle in 2006. Okay, but I digress. Okay, so now what were these enterprise applications all about? Okay, in every place except DoD. Okay, we use these ERP systems to close the books. DoD is an exception; they don't have to close the books. Okay, okay. Now but they tell us, in every place else but this neighborhood. Okay, what is our cash balances, 6 months ago, 9 months ago, 12 months ago? What are our inventory levels? What are our personnel levels? What are our payroll? Okay, what is our cost of goods sold? What is our customer churn? Okay, all of these. So we need to report in, again, every place except DoD. Okay, we need to report quarterly to our financial constituents and to government entities, what happened 3 months ago, 6 months ago, 9 months ago, 12 months ago. And if we don't report, then there's shareholders' lawsuits and everything goes to hell. Okay, so it kind of tells us with perfect 20/20 hindsight what happened. Okay, now that's kind of useful. Okay, but what's more useful? When we add enterprise AI to these applications, we can change the future. Okay, we can tell not. Let's take Boeing, classic example. Okay, where did the supply chain break down, making it so that we couldn't deliver aircraft on time? Okay, where did the inventory levels break down so that we couldn't deliver aircraft on time in full? It takes us about 440 days to build an aircraft at Boeing. It takes about 220 days to build an aircraft at Airbus, because one has their act together and one doesn't. Now, when these applications become predictive, as a CEO, we're not standing up at a board meeting explaining what our customer churn was. Okay, because we have that's an unsurvivable board presentation. Because we have the tools to tell you which customers are going to leave you, okay, in the next 180 days, so you can take action to save the customers. Okay, it's not going to be a survivable board presentation to stand up and tell your board of directors where your supply chain broke down. And in your guys' neighborhood, you call supply chain contested logistics. Okay, it's not going to be sufficient just to stand up and give, whether it's to the Joint Chiefs or to the board, explain where the supply chain broke down, when you have the tools in place that will tell you where the supply chain is going to break, so you can fix it before it breaks and deliver whether it's lethality or whether it's the automobile, on time in full to meet the need. So when things are predictive, we can change the future. We can avoid customer churn. Rather than report quarterly, as we're required to do by statute today, what our anti-money laundering events were for a financial institution. And if you don't do that timely and you don't do that accurately, see Deutsche Bank for details. Okay, you get sanctioned, and the CEO gets to rewrite his resume. Well, now when you make this application predictive, you can identify the anti-money laundering event in real time and stop it, rather than report what happened 90 days ago. That is, by writ large, the benefit of enterprise AI. Now, so we have done is we have used this technology stack, okay, at C3 AI to build enterprise AI applications. And I mean, come on, a GPU is useless, okay? It does nothing. The Elastic Cloud does nothing. Persistence does nothing of value for you. A key value store does nothing of value for an organization. Where is value? Value is customer churn. Value is demand forecasting. The value is stochastic optimization of the supply chain. The value is contested logistics. Value is predictive maintenance. Okay, that is, so in organizations where we deploy today, we are the only company that's focused on the enterprise AI stack, and we deliver, I think, today 131 turnkey enterprise AI applications that address the value chains of defense, okay, intelligence, manufacturing, oil and gas, utilities, life sciences, financial services, etc. Okay, in the long run, what vertical markets will these technologies apply? All vertical markets. Now, so our focus has been on building apps. We have 131 in the market today. In the long run, this is where the value will be. Okay, I assure you, this is the way that markets work. In the long, is NVIDIA a good company? No, NVIDIA is a great company. Okay, are these people making infrastructure like like Microsoft and AWS good companies? Holy moly, they're great companies. Okay, but in the long run, that stuff gets commoditized, and the value is going to be in the applications. So this is where we've seen it over and over again. We have companies that in this market who believe that the market is not in turnkey enterprise AI applications, and rather than build a, say, contested logistics application that you can install at DLA Class 9, DLA Class 3, Transcom, that they would much rather, send in an army of people and build a highly customized contested logistics application in each case. But I assure you that's not how this story ends, okay? So this is how we focused on it. So we have had the privilege in the last 15 years of doing business with some of the largest and most complex installations on Earth, okay? We are not primarily a beltway operator, you know that. We are a commercial, off-the-shelf software service provider, and we have the privilege of being a strategic provider to companies like Shell, ExxonMobil, Cargill, Flint Hills Resources, what have you, Dow Chemical. I think the economic benefit that and Shell would be, roughly the size of the Air Force, and their data are equally as messy as the Air Force's. And come on, everybody's got the data problem. Get over it, okay? Okay, it's just life. But at Shell, we probably have 200 applications deployed, predictive maintenance for offshore oil rigs, hydrocarbon loss accounting, well placement analytics, production optimization and refining, integration of renewables, and the economic benefit that Shell realizes from our products is about $2 billion a year. We get to Dow, where we're right now trying to get $1 billion a year in economic benefit. Koch Industries, where the goal is to get $1 billion a year in economic benefit. This is demand forecasting, production optimization. Cargill, that would be everybody's logistics problem today is kind of contested, when you get into what's happening with, the Houthis and what have you, and Iran. So all supply chain is a contested logistics problem. And there we're dealing with supply chain optimizations for about $100 billion a year in protein. And if you get that wrong, North Africa starves. So it's pretty important stuff. So we have the privilege of being a strategic partner. I think we're the world's leading provider of enterprise AI applications. I'm pretty confident of that. Okay, and we have the privilege of being a strategic partner to some of the world's largest organizations. Okay, we also have the great privilege, okay, of partnering with many of you, okay, and helping you solve problems that you're thinking about related to contested logistics, talking to intelligence analytics, talking to predictive maintenance in the Air Force. It's a relatively small part of our business. I would say about 15% of our business, but it is strategic. And the extent that we have a opportunity to participate with you, I can assure you, we take it very seriously, and we consider it a great, great privilege to do so. And so, thank you for allowing us on the team. I would say what distinguishes C3 from others in the space, okay, is we are hard stop. We are manufacturers of commercial off-the-shelf solutions, be this for the intelligence community, be it for the Health and Human Services, be it for Department of Defense, or be it for an oil and gas company. We build commercial off-the-shelf solutions, hard stop. Okay, and this is what we're focused on. I believe that we're the world's leading provider of this stuff. Okay, and what distinguishes us from everybody else in the market is we bring these applications up fast. Okay, we're breaking them up at low cost. Okay, fast, think 6 months. Okay, low cost, think first application is frequently running for order of $500,000, not hundreds of millions of dollars. And now I see this is the kind of the scale at which we operate, and it's hugely successful. And what distinguishes us from everybody in the space, everybody in the enterprise AI market, candidly, are our levels of customer satisfaction. It is what the customers say about what value they're receiving, okay, in what time frame. So I want to, my purpose today is to welcome you. Thank you so much for your time. My purpose here is to thank you, okay, for the opportunity to work together and the opportunity to learn from you. So please know that in every one of these engagements that we are committed to do with you, be it those that were underway or those that will be underway, we take this very, very seriously, and we will do whatever it takes to make these projects successful. So thank you for that. Ladies and gentlemen, thank you, thank you, thank you.